Hello everybody, I thought I would go through example A, just straight using the pages. Hopefully that's fine. So I'm going to walk you through the book and show you what they're doing. So we've started off with the framework, we've applied our forces here, and we've got one load. Why have you stopped? And we've got another load here. We've worked out the reactions. So everything's set up. And we're going to perform a method of sections by cutting it through the middle of the framework. Notice we've got 3, 4, which will mean 5 triangles. So we've got 3, 4 and 5. That's my triangles there. So this angle here, for example, if I called that theta, it's probably the wrong thing to do. Let's have a look ahead. Yeah, that is the wrong thing to do. So let's call it something else. Let's call it phi, and call this theta. So we can then write this on this triangle here, and we know how we're going to start resolving the forces. So we can see that cos phi is going to be the adjacent, so that's the 3 over the 5, and the cos theta is going to be the 4 over the 5. Alright, so the first thing that we do in method of sections is we choose which side of the framework we're going to get rid of. Normally we keep the left hand side unless there's a particularly good reason to want to throw the left hand side away. This one is really designed so that you really want to throw the right hand one away, because you've got these 3 forces, whereas on the left hand side we've got 2 forces. So that's the one that definitely we want to get rid of. So we get rid of that, and then the next thing is we're going to replace these members. So we've cut through the members and we're exposing their internal forces. And we're going to treat these internal forces just as if they were external forces, if that makes sense. So these forces now are the 3 forces that need to balance these forces here. So that's what we're doing next stage. So we've cut through the framework and we've exposed those internal forces. The notation we'll use is we'll name the force by the joints that the member is connected to. So we've got a B and we've got a C. So this force is going to be called BC. This force is connected with a joint EC. I would prefer calling it CE, to be honest, but that's what we've got in this textbook, so we'll follow the textbook. So we've got EC, and then we've got this member here which was cut, and it has EF. So we've now got our 3 forces and we now need to solve that. The best thing to do is to resolve the components of EF. So if I've got theta here, there's 2 ways I can do this. So you see we've got all this trig going on here. So we can swing the EC through theta when you swing through the angle, you use cos theta. And when you do the opposite, it's a sin. That's my little joke. It's a sine, of course. So not swinging through the angle is a sin. Okay, that'll hopefully make you remember it. The alternative that you can do is that if you worked out what the complementary angle is, you could also say EC cos phi. Okay, so there we go. So you could use this thing here. So cos phi is 3/5. Now look at the trig down here. We've got sine theta is 3/5. So both of them, whichever one you use, is going to give you 3/5. It's going to not make any difference. Okay. Let's go on to the next page. So we've got two forces going off in this direction. We've got a force going off in this direction, and then a force going off in that direction. Now, there's two approaches we could use. We could alternatively, which is the grayed out bit, is work out what that angle was, and then put the angle into your cos function or your sine function. Or you could say that I know that cos theta equals 4/5. That's what the trig is saying, okay? Cos theta is adjacent over hypotenuse. And here we've got sine theta, which is opposite over hypotenuse. So that's where the 3/5 comes from, or the 4/5. If that is conceptually difficult to deal with, then use this approach here, so the OR approach, which is that you work out, go back to that page, that you work out the angle. We could use, for example, 3 divided by 4, put it into tan, so find out what that angle is going to be, and we can use that angle to then substitute it into subsequent functions. Disadvantage of that is we start to introduce some truncation error into our solution. Conceptually, some students find it easier to follow though. So if we're going to do the approach on the left, I'm just going to talk about that approach. Then the first thing I'm going to do is sum up the forces in the x direction. So what forces have I got in the x direction? Well, I'm going to do the approach on the left. So we've got 3/5 EC. Sorry, in the x direction. We've got 4/5 EC. We've got EF, and we've got BC. So that's in the x direction, and then let's do blue for y. So in the y direction, the only thing I've got I can see is this 3/5. So they are my unknowns. Okay. So in terms of my unknowns, what we got? Let's go over that again. So for my unknowns in the x direction, I've got the BC. I've got 4/5 EC and EF. So there we go. 4/5 EC, EF and BC. They are my 3 unknowns. And we've also got this 80. So that's going in the opposite direction. So we're going to make that a minus. So that sets up that equation. Now let's look at the stuff in the y direction. So we've got this term here. That's my only unknown I've got going upwards. So I've got the 3/5 EC going upwards, and then we've got 3.333 going downwards. So this is actually a nice equation. It gives me a solution. So we've got 5/3 when I take this over to the right hand side, and then I want to flip this so it's multiply both sides rather by 5/3, I should say, and then we end up with that result. So we've found our first value. Our first value is 5.55 kilonewtons. We note that the sign is positive, so therefore it must be in tension. So what can we do now? We can take moments. Where's a sensible place to take moments here? Well, we've got quite a lot of forces coming out from this point here, so we can get rid of all these terms if we take our pivot to be this point here, and the only term we're going to get giving us a turning force that's an unknown will be this BC. This force here will be pulled back and it goes through the pivot, so therefore it cannot create any turning moment. This force here is going to create a turning moment. Okay, so that's going to want to turn in an anti-clockwise sense, and the BC is going to want to turn in a clockwise sense. So I think I should take moments about this point. And so we take moments about A. Okay, so is that the right place? Where's A? No, so we're taking moments about A, so not the point where I want to take them. So we're going to take moments about A. So the advantage of that is we get rid of these two forces. So these two forces go. I don't think that's such a big deal. Okay, so here we're going to end up with an equation with two unknowns in it. Okay, so if I take moments about A, what happens then? So if I need to go for a different colour, so if we take moments about here, well, these forces all go through the pivot, so that's not an issue. We've got a force which is going off in this direction. Yeah, so we've got the this force here going off in that direction, so that's going to create a turning moment which will be anti-clockwise, and then this BC force going to pull it back to here, so we form a right angle, and then that BC force will create a turning moment. Okay, so that's what we've got in the book. So we've got BC times 3. Is that right? So BC, you need to go back to your triangle. So your triangle is 4 along the bottom, 3 along the vertical, and 5 along the horizontal. So we've got 3, so we've got a distance of 3 times BC. Is that what we got there in the book? Yeah, so we've got BC times 3. Next one is this force here, which we found to be 3/5 EC. The distance from here to here is 4 meters, so it should be 4 meters times 3/5 EC. Is that what we have? So that's what they've done there. So we can rewrite this. We previously found what EC is, so I will then substitute that term in, making sure that I keep it positive. So I'm substituting it in there. So bring this over to the right hand side, that will become a positive term. Divide through by the 3, and we end up with BC equals 4.44, and again another positive sign, so therefore EC is also in tension. So now we can come back to this very first equation and we can substitute in our EC value. Oh, there's a typo there, isn't there? That should be BC. BC is in tension. So we can substitute our EC value, and we can substitute our BC value. So our EC value is 5.55, and our BC value is 4.44. Let's bring these terms and substitute them in. They end up as 80 take away 4.44, take away 4.44, and we end up with that result EF. Okay, so that's the approach. That's me talking through the example A using the text to take you through it. So tell me if you like that approach, or tell me if you prefer me doing a handwritten solution of what's inside the book. I'm going to do that in the next video, for example B.